where I'll be talking about various components in IoT, the architecture, various technologies used there, say like various communication technologies, the protocols, and also I'm telling you about the various IoT protocols, and also I'll talk a bit on the cloud, edge, fog concepts, and also then I'll focus a bit more on industrial IoT, and at the end I'll focus a bit on both in software and hardware that could happen actually. Okay. So yeah, so I have over 18 years of experience in end-to-end product development. So I work on various kind of hardware development, and also I work in wireless domain where I work on a wireless-based detectors, and also Zigbee and Bluetooth-based designs, etc. I've done my MTech in biomedical engineering and bachelor's in electronics and communication. Okay, so if you have any questions during this session, you can type it in the chat box, and I will answer you at the end of this session. So I'll be giving introduction to IoT, some of the definitions and all. Actually, then I'll tell you about different building blocks of IoT and the architecture. Then I'll talk on communication protocols and the technologies involved there. Then I'll tell you about various IoT platforms, and I'll also give an overview of various operating systems that you could use in IoT. Okay, then I'll talk a bit on cloud, edge, and fog computing, and industrial IoT and security. Okay, and then later I'll give a bit insight into few applications of IoTs. Okay, and then at the end I'll talk a bit on some of the IoT modules that you could use in your project. Okay, so as you are all, all of you are aware of IoT, right? Because it's used everywhere now. For example, from your remote control, sorry, from your mobile phone, you can control your home AC and other things. As the same way, you can control a vehicle actually, or you can start your car, or when you control the AC and the various things, from your mobile phone. It's all possible through IoT, yeah? Because this is this is the most important technology available now. It's also part of Industry 4.0, and it's also a basic foundation block of a digital factory. And this is the field that's will be growing actually. Okay, at the same time, Sorry, actually, I mean, somehow, net got disconnected, actually. Okay, yeah. Can you see my desktop now? Hello? Hello? Can you see my desktop? Okay, perfect. Yeah. Okay. So, yeah. Okay. Okay. So, I mean, IoT, it's a network of things. Okay. So, when you say things, so the things can be two variants actually. So, one it could be a physical things. Okay. So that is a physical thing. I mean, related to in a physical world, or another could be virtual things actually. Okay. So, physical things examples are like robots or some electrical equipments, etc. And the virtual things, so where you'll have a certain information, so it could be like a multimedia content or some application software, etc. Okay, so these are two examples actually of things. Okay, two types of things you can say. So in IoT, we have different components actually. It's made up of different components, like you'll have a sensor. So typically the sensor is for collecting the data, then you'll have identifier. Okay, so that is for now identifying the sources of the data, and then you'll have some software. Okay, so which will help you to acquire the data, and at the same time it will also do some analysis. Okay, and then you'll have internet connectivity, that is for connecting actually the data and transferring actually between various nodes, and transfer to cloud, or to different PCs and so on actually. Okay, so the main objective of IoT, it was to connect actually, various things. It could be, you have to connect the sensors, or it could be to connect the devices, or machines and people and so on actually. Okay, so this all will, help you, to, gather the information. At the same time, you could analyze the things remotely and so on. Okay, so these are some of the components involved there. Okay, so I mean, and I'll tell you a bit on how IoT works. Right, first is that I mean, in IoT network, you will have a different kind of things, and each of them will should have a unique identity. Okay, so unique identity or address, you can say. And the second thing is that thing, for example, thing could be a node, for example, here. So it should able to acquire the data, and it should able to communicate actually. Okay, so where we need to communicate the data through various protocols. It could be a Wi-Fi, Bluetooth, or an NFC, etc. Okay, and the third thing is that you need to have a some sensors actually, which will typically use for acquiring the data. And then next is about a processor, because you need to manage actually, because you have to gather the data. Okay, to gather the data, you need to also do some control actually. Okay, to the sensors. Okay, that's one thing. And also you have to do some processing of the data, that is also done by the processor. And then you have to because in many cases we'll have a large data, so we need to do some analysis. It is required for current applications, or in for future applications as well. Okay, so some of the cloud service are like IBM Watson, or Google Cloud Platform, and Microsoft Azure, etc. Okay, network, and then you'll have say a notification or control, where you'll have some sort of yeah, cloud, and yeah, other things. Okay, yeah. Okay, so I mean, things, means, it could be a sensing unit. I mean, then each of them will should have a unique address. Then you'll have a communication network, where you'll be transferring the data, and then you can be have a cloud. Okay, or it can be transferred to individual say lap computers, or to your mobile phones or tab, or wherever it is. Okay, and also it could generate some notifications and other things. At the same time, you can also control the things from your mobile phone, as I told you in the beginning. So nowadays, you have cars, which can be controlled from your mobile phone. So you can start the car, or you can control the AC and various lights and other things, right? So all those things are possible actually. Okay, with the help of IoT. So this, and I'll tell you a bit on the evaluation of IoT. So you see, initially you had things actually. So that those are individual say modules, or devices. So that can control certain things, like you have a temperature sensor. Yes, it will monitor the temperature, and it can control it. Okay, individually as a standalone component. Then you had connected things, where you will have multiple temperature sensors, for example. So that will communicate when connect with each other actually, okay, to acquire the data and to control the temperature, for example, if it is going out of range, okay. Then you have things on the internet, because then you can directly communicate to from devices to the internet, okay. So directly it will communicate with the internet, okay. And then now we have a internet of things where things can talk to each other and also to the internet, okay. So this is the evaluation actually, how it all derived actually. So this is an example actually of us different applications there. So in this case, and then the application is of automotive, okay. So so when you add some sensors initially, and when you have connected things, it is something like Bluetooth, for example. When you get a call, uh, you know you can attend the call from the vehicle actually directly. You can connect to your the car audio systems actually through Bluetooth, okay. So that's a way. Another thing is that with the help of IoT in a car, now you can also download the videos and music, etc. Okay, so that's possible. And fleet tracking, because this is a major application in automotive device. I mean, when an automotive domain, say now in school buses and all, you have all the tracking, right? So these all things are possible with the help of internet, okay. And then and it's a when you say in internet of things, you have a lot of much more than things actually, because nowadays you might have heard about autonomous vehicle, okay. So it can communicate with the different vehicles, and it can drive itself, okay. So that's one thing. Another thing is that it can also detect the traffic and other things, and it can act accordingly, okay. Also and it can communicate with other vehicles and also alert other vehicles in case of putting brake, etc., okay. So these are some of the things there. Okay, yeah. So hope you can see my desktop. Okay, yeah. So you can connect. the things in different ways actually in IoT. So one is that you can connect it via gateways, or you can connect it directly to the nodes, or you can connect it through the light nodes. Okay. So in case of gateways, you'll have a node with the sensors. Okay. So then you connect to first to the gateway, and from there you'll connect to through the router. Okay, to the internet. Okay. So this is one way of doing it. The another is that in your sensor itself, sensor node itself, you'll have a Wi-Fi, Wi-Fi and also IoT agents, so that you can directly communicate actually. Okay. So that way the communication will be much better here. Another thing is that you can also connect it through a gateway and the router actually directly to a net actually. Okay. So this is the third option actually. Okay. So yeah, I mean these are the building blocks of IoT. So as I told you, in IoT you have a node, router, and cloud. Okay. So cloud is based on multi-core processors. So it could be a processor, or a DSP, or an FPG, or GPU, etc. Okay. So because you have to process large quantity of a large amount of data, and also you have to analyze it. Okay. So in addition to that, you have to also interface external memories actually for the storing purpose actually. Okay. So all those things are taken care by this multi-core processors. So in the node, you'll have sensors. Okay. So the node is typically battery operated, so we have to ensure that the power consumption is low. Okay. So the node will have a sensor, so that will convert the physical signals into electrical signals. Okay. Then you have to do some amplification, filtering, etc. That is done by the signal chain circuit. Okay. And once you convert that signal into digital, you'll take that data into the processor, where you do further processing actually. Okay. So once the data is processed, you will send this data through the wireless module. Okay. So where we'll use different kind of wireless technologies. Okay. Then overall, you have to manage the power also actually of the node from the microcontroller. Okay. Because it has to control the power in such a way that it will be consumed low power, so that you can use the sensor. I mean, you can use the sensor node, the maximum possible time. Okay. So these are the building blocks of IoT. So in IoT, I mean, typically, see, if you have a think, then you'll have some sensors or actuators, where you'll have some I mean, intelligence actually. Okay. So suppose the thing is your refrigerator, so you want to control set the temperature, so you'll have control board, which will have some sensors. I mean, and also some processors to do that actually. And okay, so then it will also have some connectivity, where you could connect your refrigerator to your mobile phone, or from to net, where you can control it directly. You can access your refrigerator, and you can control various parameters like a temperature, in the freezer section or other parts, for example. Okay. So in IoT, like you'll have a sensors, you'll have a microcontroller to overall manage the processing and control of the sensors, and for the data acquisition. And then after that, you have to send the data you know through the various wireless protocol actually, protocols, to transfer it to other devices, or through the router, or to the cloud. Okay. So there, once you get the data in the router or gateway, so what we'll do is that further get to process the data or filter it. Okay. So, and some part of the data may have to be transferred to cloud, and it has to be stored there. Okay. Or you can control actually, or control, or you can report or analyze the data. Okay. So this is how it is done actually. So as I told you, for example, in the fridge, refrigerator, you have the data, you can control from net or mobile phone. Okay. So for that, you need to have a module here, which will transmit the data. Okay. And then from your mobile, say if you assume you are transmitting through Bluetooth, you can acquire directly from your mobile. Okay. Mobile app. Okay. So it will detect the data, and then you can control it. Okay. So this is how it is done. So these are the building block of a sensor node. So sensor node, so, it's the starting point in any IoT. Okay. So you can have a different kind of sensors. Okay. So all the sensors will be in the interface, in the sensor subsystem. Okay. Sensor subsystem will have a sensors. Okay. It will have some signal conditioning and analog to digital conversion circuit actually. Okay. So you will measure various parameters like a temperature, humidity, the light, and so on actually. Okay. So once you've processed the data and converted, you can interface that with the processor. Okay. So the purpose of microprocessor here is to uh, acquire the data, and at the same time to control also the sensors, because sometimes you need to control also the sensor to acquire the data, because in the reality, you may not be acquiring the data continuously actually, because you have to overall reduce the power consumption. For example, you have a temperature sensor in a factory, so you need not read the temperature always. You have to read periodically. So that means by the time when you're not using the sensors and the respective circuit, you can switch off it actually. So that way it is possible actually. That is the reason, one of the major purpose of the processor. Okay, so one is to control, then you need to acquire the data. So the data can be acquired through different ways actually. It could be through I2C or SPA, or even maybe you can acquire the data directly. If it is unlocked data, you can connect to the analog to digital conversion port of processor and so on. Okay, so you'll have memories to store the data and so on. Okay, so once you process the data, so then you have to transfer the data through various Wi-Fi modules actually. I mean, communication module. So it will be interfaced to a communication system where you'll have radio chip and some processors. Okay, so from there the data will be transmitted. Okay, so this is the typical process involved in this sensor. So first is like you have to sense the things. Okay, so that's where that is very important actually. Okay, so you'll have a different kind of sensor, so you need to amplify and filter it actually, and then you need to convert to digital, do some processing there, and sometimes you may have an actuator in there. So for example, you have a temperature sensor, then finally you have to control the temperature, you have to maintain the temperature. So have certain control mechanism in place. Okay, so I mean, first is to sense it, then process it, then you have to convert actually. Okay, so this is how it is done actually. Okay, so this is the node level architecture. So if you see node, you have got different kind of components in the node actually. And so one is like you have various kind of sensors. The next thing is the energy interface, because the node will be many times remotely located, so we have to power it actually. So there could be multiple sources of power. It could be battery, or it could be from energy harvesting. Okay, so I'll tell you a bit on that later. Then you need to also maintain you need to have the clock actually to run this complete circuit, and also sometimes you need to trigger it actually, internal trigger or external trigger actually. Okay, sometimes triggering events will be there, because suppose in the border you have some sensor, so if it is to detect somebody, then when the person is there, so you need to trigger it actually, so that it will acquire the data and process it. Okay, then you have processing unit where you'll process the data. So you'll have processor there, and it will have to interface with different kind of memories. Okay, for the storing the data, and also we need to have a lot of encryption technologies in place actually for the data security. Okay, okay, so then we have to transfer the data through wireless protocols. Okay, okay, so we have to transmit the data through this various wireless protocols. So we'll have an antenna, I mean, and also communication chips available actually. Okay, so then some of this output you should transfer actually. For example, you want to control the temperature, so then then you need to activate the cooler unit, for example. So for that you need to transfer the data. So sometimes it could be digital lines, or it could be analog interface, etc. Okay, so this is how it looks like. So the major building block of IoT is a sensor, because that's a major in the first thing, because we need to sense the data. Data means there some event or changes in the environment. Okay, so that's the first thing. Okay, so this is a front end in for IoT. Okay, so that's one thing, and then you will have an actuator. So sometime you have to control something actually. So where actuator is need. Okay, so nowadays you have got smart sensors. So these are very portable sensors which will have the sensors, and also the signal conditioning circuits and some processors, and the transmitter and all. Okay, for transmitting the data in a single module. Okay, so this will help to have everything in a single place, so that you can directly transfer the data to a gateway. Okay. So the typical characteristics of a sensor is, one is that sensor should consume low power. This is very critical actually, because we have to reduce the power consumption. Second is that sensitivity. This again very important. It depending on application to application, because in some cases where you need to have a very accurate temperature measurement and control. So in that case you need to have high sensitive sensors actually. Okay, then the accuracy is again very critical. So we need to have a low with very high accuracy, so that we can have a low errors actually. Okay, resolution is again very important, because we need to detect the smallest changes actually. That's again important. And the reliability is again important, because many time it is used in remote location actually. Okay, so again it plays a major role there. Okay, So I mean, so RFID is one of the building block. I mean, in some of the IoTs, you can say. So the RFID tags are there. You might have seen everywhere. It is there in supermarkets or in the factories. Whenever we have, we'll use some components actually. So we'll have tags attached to it. Okay. So what we do is that we'll you have a reader, so we will read the data so that we'll get the complete information of these devices. Okay, and then you will send this data to a PC. Okay, so by doing that, it will help you to understand when the device is used or the particular product is sold. Okay, so by doing that, you will have a clear indication on your stock, or the part availability, etc. Okay, so that will also help the organization to order and so on. Okay, so in the tag you will have a microchip actually, which will have complete information of of the product and its serial number and what cost and all of the things actually. And also you'll have an antenna actually to transmit and receive the signals. Okay, and then reader will read out the things actually. Okay, and will also finally emit the data through the antenna, and so you can get in the PC directly. Okay, so this is how it is done commonly. And so I've told you about a microprocessor. So that's one of the major building block in IoT, because we need to manage the sensors, and you need to also communicate actually between various nodes and so on. Okay, so we have to consider various things while choosing the processor, because we have to see the how much processing power you need, and which type of software you want to run, which type of operating system you want to run. These are some of the things you need to consider. In addition to that, you also need to see the power consumption of the processor, the memory interfacing part of it, and what are the other type of interface that the processor support, etc. Okay, and also you need to consider the development tools and other things. So ARM, MIPS, and x86 are some of the processors commonly used in IoT. Okay, so a bit on the power part actually. So typically node is battery operated. Okay, so especially if it is located outdoors actually, so we need to have a long run actually of this product, means we need to reduce the power consumption. Okay, so so that is very important actually. Okay, you need to have a battery with good charging storage capacity actually, so that's very important. Okay, but at the same time, battery also has got a lot of disadvantage, because if you want higher storage capacity, that means the battery will be heavy. Okay, so that is one issue. And another thing is that once the battery is drained, you need to have an option to recharge actually. Okay, so this is again a disadvantage. The third thing is the maintenance cost is again high. Okay, so that's also one of the reason why we are looking into other opportunities like energy harvesting, because this is a common approach that is used in outdoor sensor nodes actually. Okay, so this will really help you to monitor the data, monitor the energy available. Okay, and also to convert the energy, like solar energy, etc. Okay, so you'll have photovoltaic cell. Okay, so that will convert the solar energy into electric energy. Okay, and then you'll be storing in the battery, and for future use actually. Okay, so this is how it is done. Okay, so you have a different kind of battery, so depending on type of applications, you could use various kind of batteries. Okay, so lithium ion has got a better storage capacity, so you need to consider these things while you choose various kind of batteries. Okay, so energy harvesting, as I told you, this is a common practice actually. So I mean, photovoltaic cell is one of them actually. So typically in energy harvesting, you will have photovoltaic cells. Okay, so that will convert the solar energy into electrical energy. Okay, so but at the same time, you can't use it directly. The reason is that the output voltages from the solar energy, it will vary frequently depending on the sunlight. Okay, so we can't use directly. Okay, so what you need to say, for example, you need to have a power management system actually for the energy harvesting. Okay, so you'll have a source there. Okay, for example, your solar cells. Okay, so then you will get get the electrical signal from there. Then we need to control this actually, really to use it in the system. For example, you want to operate your say processor at 3.3 volt. Okay, so whatever supply you are getting, sometime what happens, there will be drastic variations in that actually. So we need to have some control mechanism, okay, power control mechanism, where you need to monitor the output actually of the solar energy, and also you need to control it actually. Okay, so we need to have certain type of regulators, say buck boost type of regulators. So typically what it will do is that when the voltage is low, it will boost it, and when the voltage is high, it will reduce it actually. So these all things will overall help you, to ensure constant supply to the source, I mean to your node actually. Okay, so this is one aspect. Another thing is that we need to also store the energy. Okay, because during the night, there won't be any like solar, right? So you will not have any charge. Okay, so you need to store it in the batteries or super capacitors, super caps. Okay, so these are common energy sources used actually, so that the energy will be stored. Then, and when there is no solar energy, or if the solar energy is less, then it can be consumed there. That way, you can increase the life of your node actually. Okay, so this is a common way it is done already. Okay, in various type of applications, outdoor applications. Okay, so there are various modules which I've told you. So these are the functions of that, and the conduct power conditioning and control module is a very critical one, because we need to clearly monitor. Otherwise, it could affect the operation of your node actually. Okay, so bit on the physical layer. So overall, if you see in IoT, you'll have sensors, then you will have source encoder or ADC, which will convert the signal. Okay, and then you have to encode this signal actually. So that is very important actually, to ensure the signals are immune actually to noise, and at the same time you have to also encrypt here. Okay, so that nobody could access the data as it is. Okay, then we have to modulate the data while you're transferring actually, to ensure that you could transfer the data and long distance actually. Okay, and at the same time to ensure that it will not have any impact on external interferences and so on. Okay, so once the data is transferred, you'll have a power amplifier, so that is required, because you have to increase the power of the signals that you want to transmit, and then you'll be transmitting through the antenna. Okay, so on the receiver side you will get the signals, and then you will do the demodulation, and you do decoding of the signals. Okay, so this is how it is done. So yeah, so physical, layer will define, the hardware aspects of the communication link actually. Okay, so the different modulation method, and which medium you want to try, use the data transfer. For example, some cases, your node could be even wired one actually. Okay, so that is possible in factory sometime. Okay, so sometime it could be directly wireless module. Okay, so this link layer, in the, it'll also provide a lot of service, like it will be implemented with the combination of hardware and software. Okay, and then so medium access control, that will overall control the link layer actually. Okay, and the hardware also, for interacting with the various communication mediums and modules, etc. Okay, so this I've told you about the source encoding. So that is for converting to analog to digital signal. Okay, and here we do some encoding and other things for further actually. So we here we will also do encryption actually, to ensure that the data can't be hacked actually. For example, so then modulation, you can do in different ways, like it can be amplitude, frequency, or phase modulation actually. So that is very important for to improve the immunity to external interferences. Okay. Okay, so then finally, in this, physical layer, you also have an antenna finally, because the antenna will be transmitting all these signals actually through, the medium. Okay, so we have to consider a lot of aspect actually, while you choose an antenna. Okay, because the transmitter side, antenna will transmit the signals actually. So you need to choose the antenna according to the type of the protocols you'll be using, and also how much range you need actually. Okay, so in the receive side, and finally the antenna will convert the electrical and the energy, say the voltages, to electromagnetic waves actually for the transmission. And the receive side, will convert these signals back to electrical signals actually, and you process it further. Okay, after receiving it. So there are different kind of antenna. So so the chip antenna is the smaller one actually. So this is quite popular actually. Okay, because it's a small one actually, and it's good for in mid-range application and other things actually. Okay, and it's a quite the cheap also actually. Okay, and then you can have your own type of antenna, custom one actually, and then wire type antenna is also good actually. Okay, but then you need to have a good protective mechanism for this antenna actually. Okay, so depending on the type of applications and the range or the frequency that you want to use, you need to choose the antenna. Okay, so the VIP antenna is another. This is commonly used in the router and all. You might have seen it actually in the Wi-Fi router. These kind of antennas are common. Okay, but this has got really good performance, but it's not always possible. In the node you can have such antennas. Okay, so then the PCB type antenna is also very popular actually. This is also quite good actually. Okay, because it's directly designed in the PCB. Okay, so that's a biggest advantage of this kind of antenna actually. But it has got restrictions in terms of the performance actually, and at certain frequencies you won't able to use it actually. So you need to consider your application and which type of what kind of system you are going to do, and what is the data throughput you need, and also the frequency you want to operate accordingly. You need to choose the antenna. Okay, so in IoT we have got three layers. So the one is physical layer, then communication layer, and application layer. Okay, so in the physical layer you'll have a sensing and actuation, where here you'll have the nodes and other things. Okay, so the examples could be RFID tag, for example. So they are wireless sensor network. That's an example. Then in the communication layer, you will use some of the communication technologies for transferring the data, like Bluetooth or Wi-Fi and so on. Okay, and then in the application layer, you'll be running certain applications actually for controlling various things. Okay, so now I'll tell you a bit on various communication technologies. So I mean you've got different communication technologies, from NFC to RFID to Bluetooth, Zigbee to Wi-Fi, and a lot of other things. So you have to choose it based on various aspects, because all this technology is different in terms of the range through with through which they can transfer the data. Okay, that's one thing, and also the data rate. Okay, so these are very important aspects you need to consider. Okay, so the major drivers for selecting the particular communication module is based on your application. Okay, so you have to consider various things. So one is like a wide range actually. So you need to see how much range you want to transfer the data. That's very important. And the second thing is the cost actually. Okay, so you need to choose something which is cost effective for your application, and the power consumption should be very less actually. That's again very important. Okay, and in a network capacity you have to consider, and the data throughput is again very important, because if you want to transfer as a video in a drone and all, for example, so you need to have such protocols, or the communication technologies. So you cannot have Bluetooth there, because Bluetooth cannot transfer data at that range actually. Okay, so you need to choose something like that. Okay, then you need to look into the reliability aspects, and the latency. You should have very low latency. It should be really quick enough actually to transferring the data. Then it should also support a lot of security applications, and those things things should be there actually in place, so that nobody could access the data. Okay, so RFID is one of them, so which I've told you before actually. So there you'll have a tag actually attached. Okay, so then with the reader you can track it actually. Okay, so there are two variants of tags. So one could be active, so they can have their own power source actually. Okay, so you can read a bit long range actually, say up to 100 meters. In the passive tag, you will not have a power actually directly, so it will be powered through the electromagnetic energy actually, from transmitted from the RFID reader. Okay, so they can read it from short distance only. Okay, so these are commonly used in the malls and in the shops and other places. Okay, so then you have NFC. So you might have seen it commonly. It is there in your credit cards or debit cards, and even office IDs, etc. Okay, so it's a very near field communication, and it operated 13.56 megahertz. It's only for used in peer-to-peer communication actually. Okay, so it can be a reader or a tag actually. Okay, and it is support only very short distances, so that's why it's used in only this kind of applications. Okay, then you have Bluetooth low energy. So Bluetooth low energy is quite popular. I mean because it can transfer the data, say like up to 100 meter, and also throughput is 1 megabits per second. Okay, and this is a low energy version of the normal Bluetooth. Okay, so so the advantage here is that this has got a sleep mode actually, so that when the device is not in use, I mean this will go in sleep mode actually, so that way it will consume very less power. Okay, so then you have LoRa. So I mean, this is used, where you have a very less data to transfer, but you want to cover larger distance. So for example, Bluetooth will cover only 100 meters, but this can support up to 15 kilometer. So for example, in the border, say like you want to detect, so somebody is coming actually to our country, for example, the border. So you can have this type of wireless sensors, with this LoRa protocol. So where your base station can be say 15 kilometer away actually from the router, so that you can collect the data that much away actually. Okay, so that in such kind of application it's very useful. And also here data the rate is very less, so there whether we need to, there our aim is to detect a person whether he's there or not there. Okay, so such kind of application is suitable. Then you have a Zigbee. Okay, so Zigbee, and also in a low power protocol actually. Okay, so this has got range up to 100 meter. Okay, but the throughput is less actually compared to Bluetooth. Okay, so this again used for shorter distance communication. Okay, and one advantage of this is that in many countries, it operate at different radio band actually. Okay, so that will means it will not interfere with other bands, like 2.4 gigahertz is a common band use. Okay, so that way it will not have much impact on interfacing interacting with the other band and affecting overall the bandwidth and other things. Okay, so Z-Wave is another protocol actually. Okay, so it is used for home automation and all actually, typically where you can control multiple devices, say up to 232, and also you can transmit the data over 100-meter range with up to 100 kbps. Okay, so this again is at a different frequency band. Okay, so on Wi-Fi, as you all know, it's I mean, very popular. Okay, so Wi-Fi has got different variants actually. So all of them cannot be used typically in low power, IoT applications. Okay, so you have got a special protocol there, like especially for low power. Okay, so 802.11ah. Okay, it's a Wi-Fi Halo. It's called Wi-Fi Halo. So this operated 900 megahertz band actually. Okay, so here you can see it can transfer the data up to 347 megabits per second, and it can cover large range. So it is commonly used in drones and all actually. So you want to take a photograph, then you could transfer within 1 kilometer range actually. Okay, then this is I mean six low pan actually. So this IPv6 wireless protocol actually. Okay, so again the throughput is less here, but it can transfer the data at a longer distance. Okay, then Li-Fi, probably you might have heard about it. It's a high-speed communication, based on visible light actually. So where you'll have LED transmitters actually, and it will be used to transmit the data when it's extremely fast. It can transmit the data up to 100 Gbps, but you have got a lot of challenges there because it is only short range communication, and if you have any walls and other things, you can't transfer the data. So it's typically used to transfer the data between a monitor and your transmitting device, which will be in the same room, for example. Okay, so cellular technology is also common technology used in Wi-Fi. So here, sorry, in the IoT. So here, the biggest advantage you are having here, the range actually. So that SSPA protocol and all, now it can even support up to 200 kilometer. So this is really useful actually in such kind of applications where you need a larger range. Okay. So when you are comparing various communication protocols, you have to see multiple things. One, you need to look at the range that you need, what speed really you need actually, and then also you need to look at the battery life actually. That's again important. Okay, and the cost. So you need to consider depending on the application that you want to use. So if you want to transfer some image and also, always go with the Wi-Fi, because it will support that. Okay, and if you have some audio files and other things, Bluetooth is a way to go. So this again a comparison actually, where I mean we'll be talking based on the the distance you want to transmit the data, and also the data throughput and the power, because these are the important aspect you have to consider while you choose a protocol. Okay. Okay, so this is again a comparison actually. Okay, so different protocols and the range and so on. Okay, So so those are the communication technologies really we use actually in any kind of communication protocols within an IoT. Okay, okay. So so those are really critical actually whenever you to use in your application based on your need actually. Okay. So the next thing is the communication protocol. So I mean it's a set of rules actually. Okay, so that will allow you to communicate with a different kind of devices and so on actually. So and it will these protocols will actually define the syntax and the semantics and synchronization, etc. So that will be taken care by these things. Okay, so there are various communication protocols. So one of them is HTTP. Okay, so all of you are aware. So this is behind the World Wide Web actually. Okay, so it's a client server architecture. Okay, okay, so it is operated based on the request and the response fashion. So for example, client will send a request to the server and server will send a response actually, and that way you'll communicate actually. Okay, so it uses a TCP. Okay, so then you have WebSocket. This is quite popular actually. Okay, so it is for use for web browsers actually. It provide full duplex communication. Okay, so it is commonly used for real-time data transfer and the streaming of messages, etc. So it's there in Firefox or Google Chrome and the Internet Explorer, etc. Okay, then you have XMP protocol. So this is another one actually. Okay, so it will also help you to transfer the data by via instant messaging and so on actually. Okay, so it has got quite good security features. Okay, okay, and it is typically used in the servers and like clients, etc. Okay. So MQTT is, I mean, again, I mean, another type of, the communication protocols. Okay, so it's typically used in machine-to-machine communications, and it's developed by IBM actually. So it is operating, based on a publisher subscriber model actually. Okay, so publisher will send the data to the server. Okay, okay. So this is the server here. Okay, and the subscriber can receive the data actually. Okay, so it will distribute the data and then subscriber can access the data. Okay, and or I mean, or you can request for the subscription actually. Okay, so it's a lightweight protocol actually. Okay, so it is quite fast actually, and it will also consume low power. Okay, okay. So then you have a COAP protocol. Okay, so it is used for application where you have a very limited computing power, or you have a network connectivity, etc. So it's based on UDP application, and it's also used in machine to machine applications, like in home automation or building automation, etc., where you'll not have much data to do. Then you have MQP protocol. Okay, so it's a message based protocol actually. Okay, so so it will follow certain rules actually, like it will do typically exchange the data. Okay, and it will also store the message actually, until the it is processed by client actually. Okay, and it will also define the relationship between different components in the system. Okay, so these are something which you need to consider while use it in various applications in IoT. Okay, so there are different levels actually in the IoT. So one is you'll have a device stage where you'll have a different kind of IoT devices, nodes, etc. Then you'll have a network, where through where you'll get the data actually through the gateway and cloud, etc. Okay, then you'll have management platform where you'll overall manage the data, and you will control it actually, and you will get the data. Okay, because you can control all the sensors and other things from here. Okay, so then you will have finally application. Okay, where you'll be running some application actually, for example like billing and so the other things actually. Okay, so you'll have their device level where you'll have a sensors, then you'll have network level. Okay, so you'll have some gateways and routers and so on actually. Okay, so in the application level, you will perform all the analysis, and you'll also manage the things, and control different sensors and sensor node and other circuits, etc. Okay, and the application will be running on the application layer. Okay, so if you're seeing the mapping of IoT to network layer, so it is a mapping map directly to a network layer. Okay, and these are the different layers in the IoT. Okay, so like physical layer, you have a link layer, networking protocol layer, and then transport and application protocol and application service layer. Okay, so this is very important actually. So the application layer, and application service platform. These are the major the additional things actually for the IoT layers actually. Okay. So the application I mean, a protocol layer, their responsibility is to handling the communication between two different things, or gateways, etc. Okay. So they will support in reading or acquiring the data, okay, from things actually, and also to control the data or trigger it and other things. Okay. So that is run there. Okay. So, and then we have various IoT platforms. So the in IoT, finally, it's all internet, right? So you have various sensors. Okay. So finally, we have to connect the different sensors, and the data network actually. So that's very important actually. Then only we'll able to acquire the data. So there are a lot of platforms for IoT, so which will help you to connect with the verb, connect to various devices or sensors and nodes, etc. Okay, and also it will help you to analyze the data. And you can also control the sensors. For example, you can monitor the energy left and so on actually. And also you can control the sensors, and sensors can alert there are any problems actually, and so on actually. Okay, and also your software will be running on the platforms. Okay, there are a lot of platforms available. So IBM Watson is one of them. It is a cloud-based, IoT platform, and it has got AI and analytical software actually for analysis purpose actually. Okay, and it has got a good lot of security features actually, and the software development kit is available for embedded C and Java or Python, etc. Okay, so this is something which you need to consider when you are choosing IoT platform, because you need to also see what are the languages and other things that is supported actually. Okay, then you have Eclipse actually. It's an open source platform. Okay, so this also used in the IoT device or cloud actually. Okay, so it is an open source one actually, and it will also provide in all the framework actually for developing an application. Okay, so Amazon AWS IoT is popular one. This is yeah, also used to communicate your devices with AWS actually. Okay, Amazon Web Server actually. So that will help you to communicate with them. Okay, so and it will also help you to connect with various devices, and interact with them actually. Okay, and it support protocols like HTTPS, WebSocket, and MQTT. This is one of the important thing you need to always consider when you are choosing a platform. I mean, because this platform should support. Okay. Then you have a Google Cloud IoT. Okay, so this is from Google actually. Okay, so they also have a lot of security features. Okay, so they also support Java and .NET and Python, etc. And you have a Microsoft Azure IoT suite. Okay, so this will also help you to communicate with the various IoT device, control them, etc. Okay, so and then this provide a lot of APIs actually. So one of the APIs for artificial intelligence service. Okay, and this also support HTTP and MQP and MQTT. Okay, so these are something which you need to consider when you are developing a complete IoT, because you need to have a proper platform. At the same time, they choose an protocol should support there. Okay, so then I mean OS is an important factor in IoT, because so OS is it use to manage the complete operation of your system, where like it will manage interact with the hardware resource, and it will schedule and prioritize the task. Okay, and suppose so two applications are running, it will prevent the contention and other things actually. So this is a very important aspect. Another thing is that it will also manage other tasks like memory management, power management, and file management. Okay, so these are also very important. Okay, so there are different kind of operating system available. So one is a single task operating system, where it can be used only to perform single task at a time, or multitasking, where you can perform multiple tasks actually. Okay, in parallel actually. So you need to choose the one that is needed actually. You okay. So most important thing you have to consider while you're choosing an operating system for IoT application is, like you need to always look into the memory requirement. Okay, so that's very important. And also the energy, and energy or the power consumption part of it. Okay, these are very important actually. In addition to this, it should also support a lot of security features actually, and also it should support various network connectivity and protocol support actually. This again important because some of them will support only certain Wi-Fi communication technologies like Wi-Fi, Bluetooth, etc. So you have to always consider this aspect. Okay, so then it should also support various hardware. Okay, so all those things need to be considered. So TinyOS is one of them. Okay, so I mean it's an open source actually. Okay, so it's you can develop the application and also it support NSC actually. It's a variation of C language. Okay, and also it support various microcontrollers like MSP430, ATmega, and ARM, etc. Okay. So then you have another OS called Contiki actually. It's for low power applications. It is used actually. Okay, so it is supporting scope and low pan and RPL, etc. So it won't support for example Bluetooth. So these are the things you need to always look when you're choosing a operating system, because when you're even choosing an communication technologies, you need to always see all these aspects. Okay, and it require only 10 KB of RAM and 30 KB of ROM, etc. Okay, and it supports C language and it support various processor, but it does not support ARM. Okay, so you have to understand this. Then you have Android IoT. Okay, so this is support Bluetooth and Wi-Fi, and it require around 30 to 64 KB RAM. Okay, so then you have right. It is another IoT. Okay, so it supports C and C++, and also it support various processors actually. Okay, so then Cipher is another one actually. Okay, so Cipher it's made by Linux. Okay, so it also support a Bluetooth and Wi-Fi and NFC, etc. Okay, so but the problem with this is that it consume much more memory compared to the other one. Actually, it need larger ROM actually. Okay, so there's a comparison of different operating system. So you need to consider a few things while you select a operating system. One of them is that which all the communication protocols it support. The second is that which all processor it support, and the third thing is important, that is about the memory requirement, and the fourth thing is the power consumption. All those things you need to consider, and also you have to see whether it's about multi-threading, etc. Okay. So in IoT in a high level, if it's like you can make the architecture into three domain. Okay, so one is like a sensing domain. Okay, with this is the domain where you'll acquire the data. Actually, you sense the things. Okay, and then you'll have fog domain, because this is a gateway domain. In between, it will do certain task actually, and then finally the cloud domain. Okay, so these are the three domains. So if it's in the fork domain, so fork domain, the purpose of doing is that, you want to transfer the data over the internet, okay, and you want to analyze it in the cloud, okay. But all this thing will take enough time actually, okay. So it's important for us, to have another hardware in between actually, where you can do some sort of data allocation, data collection, data monitoring, analysis, etc. So it will help to control the node easily actually. Suppose if you cloud want to control a node, okay, typically hundreds or thousands of nodes will be attached to a cloud finally, okay. But to control, it will take time, and sometime it will be even cause a bandwidth issue, because you have many nodes to control. So it's good to have a fog in between actually. So that is a common way it is actually, and that's, so fork device will control each of them locally actually, and and it'll have manage the storage, and for the additional processing, and finally it will send you cloud. Okay, so this is how it is done. Okay, so if you see in the in IoT, you have the device node. That is the first part actually. Like you'll have sensors and other things. Then you'll have fog node. Then you'll have cloud node. The purpose of fog node is to reduce the burden on the cloud. Okay, because if a cloud want to perform all the data, acquire all the data and perform the the thing analysis and other things, it's not always possible, because it take really lot of time. You take the case of a traffic, the cameras and other things, right? Because you'll have hundreds of camera, okay, so you cannot have everything into cloud actually. So what we do is that locally we'll have fog. So it will all send the data, say maybe for example in a particular highway of say maybe say 50 kilometer, one fork node can manage it actually like that. Okay, and then fork node will do the analysis initially, and it will send the details to the cloud actually. This is how it is done. Okay, by doing that, you can improve the throughput, and also you can ensure the analysis is done quicker actually. Okay, so yeah, device layer, yeah, so I've told you that. Okay, so it is a fog is the layer between device and cloud actually. Okay, so it will be very close with your nodes actually, so it could acquire the data and control everything actually. Okay, so it even will have a storage unit actually. Okay, so cloud, so applications running in servers, or or and that can be accessed by clients over the internet is called cloud applications. Okay, um, so cloud applications will allow the subscribed clients to access cloud services actually. So you can access various services, like you have Amazon cloud and lot of other things, right? So you can access various things actually. Okay, so in if it's in cloud actually, in IoT, generally the cloud service include the sensor things, control actually. So it will communicate with the things, okay, to collect the data and control actually. Okay, so this earlier case, we were not having the fog actually devices in between, so it will control directly. Okay, so then cloud is typically used for various other things. So one is for storing the data because it has got large storage. Then you need to present the data on a website, and mainly analyze actually and create the report, because data analysis, big data and other things. So all those are part of coming under cloud actually. Okay, then you need to also alert various users. It could be alert, could be a text message, or it could be an email. Okay, and it will interface with various applications actually. For, as I told you in the beginning, yeah, so in a factory, you will have a the storage and the warehouse information, where you will always have a stock information. Okay, so when products are getting manufactured, you will use various parts. Okay, so with the help of the cloud, you will track all the use part, and you will also get to know how much parts are remaining. So the ordering and other things can be done much efficiently actually, because people will have an idea actually, wherever it is. You need not come out physically actually, so you will get to know, you get an alert when the stock is under certain level. Okay, so it will also interface with various applications and so on actually. Okay, so I've told you cloud computing actually. Okay, so it will help you to for the analysis also, and it will help you to store the data and so on actually. Okay, but the problem with the cloud is that because you cannot have so many nodes connected to it always, because that will have an impact on its bandwidth, and also it will create a lot of problems actually in congestion and other things actually, and delay. Sometimes you'll have too many nodes who want to communicate with the cloud, so you'll have to wait. Some nodes has to wait longer time. Maybe by doing that, we'll lose a lot of time actually. And if in data, if it are time critical applications, it will be a challenge actually. Okay, so in a smart grid and other things, you need to act very quickly actually. So those things are very critical, and latency is another problem, very level delay actually. So we need to have a fog computing in between. Okay, so that's where fog is coming in picture. Okay, so edge is part of a fog computing actually. Okay, and so it's a distributed computing system actually. Okay, so it will be located very close to the nodes actually, where where you'll be collecting the data. Okay, so the purpose is to decentralize the things actually. Okay, because we need to acquire the data at a closer. Okay, and then you need to eliminate the time take for the data transfer and processing, etc. Okay, so it has got some intelligence, processing and communication capabilities, etc. Okay, so this is very important actually. Okay, so in the edge, if you see, like data is collected actually and analyzed by this actually. Okay, so then later it will be sent to the cloud. Okay, so it is for local analysis purpose actually. So Microsoft Azure IoT Edge is an example actually. Okay, so this is an edge computing commonly used. Okay, so here, the communication is simpler because it's very close to the node actually. A set of nodes are close to each other with this edge computing. So where, you could process the data, okay, and you could analyze the data, okay. So it has got the three things. One is edge devices actually. Okay, so that will be connected devices like sensors and other things actually from where you get the data and you analyze the data. Then you'll have a gateway. Okay, and that is responsible for connecting edge with the cloud environment. Okay. Okay, so then the cloud environment further analysis will do. So you will do filtering here actually. Really, suppose you're having a traffic, this cameras in the road actually, right? So it will detect whoever is driving fast, and they will detect that actually, and only those information will be sent to cloud. Otherwise, you imagine when a camera is detecting everything, lot of information, everything has to be sending to cloud. It will take time, and it will cause also wait time and other things, right? And it'll cause the latency finally, and it'll have impact actually in safety critical applications. Okay, that's where edge play alone. So for computing is based on edge actually. Okay, so where so the edge will do many of the things actually. Okay, so all the computation, storage and analysis, etc. Okay, so it will process the time sensitive data. Okay, so because it is very close to the device. Okay, so it's an extension of cloud. Okay, so for storing the data, and it's very close actually. Okay, so and it is the main advantage is that it will bring the function close to where the data is there. Okay, so like to the sensor. Okay, it's not an alternative cloud. So if to because in a system you have to have both actually, because it will take care of local things, and then globally cloud will take care. Okay. Okay, so it will it is based on edge, as I told you before actually, and it is very close actually to your the devices. Okay, and by doing that your latency can be reduced, and your service quality can be improved actually. Okay, so and it is quite fast actually, because it is very close to each other there. Okay, and it has got the storage and the computer networking powers actually features actually. Okay, so you can build the application around this actually. Okay, so in the fog, typically first thing is that we need to get the data actually from various devices. Okay, and then we need to transfer the data to the cloud environment. Okay, so the communication is first coming from from your let's say programmer control actually, so that will control various devices and all actually. Then we will send to the gateway. Okay, maybe in HTTP or something. Okay, so then we will transfer finally that the data to the cloud actually. Okay, so this is how it is done. So there's an architecture, because there are a lot of layers in cloud actually. You'll have a sensor layer, then you'll have a device. Okay, then you'll have the data streams generated from there. Then we'll have a layer to monitor and control actually. Okay, so then it's you have to manage the resource there, where when the scheduling, etc. So all those things are done there, this layer. Okay, then you'll have application modules where you need to sense the data and control it and so on actually. And then some applications will be using all of the things. Okay, so like medical or industrial and so on. So these are various components there, so which I've told you actually. I mean so you need to collect the data, then you need to monitor everything. Okay, then you have to manage the resource actually. So this is very important actually. Okay, so here use APIs actually for monitoring and controlling actually, and also managing memories, etc. Okay, so finally it has to run on some applications. Okay, and it is used actually in various applications. Okay, so in the fog, if you see, like you have a three segments, so which I've told you before, like you'll have a device actually. Okay, so you'll get a lot of data from these devices. Okay, and then you'll have a network of different fog devices actually. Okay, so which will be connected to each other. Then finally you'll have a cloud through to where you will send the data actually. Okay, so the advantage of fog is that you will do part of the intelligence to the local area network actually. Okay, so that the cloud will be having enough access actually to other aspects actually, so that the bandwidth can be improved actually. Okay, the comparison you can see here. I mean, so cloud require a huge bandwidth actually, and it's unreliable actually, and and also fog, it will reduce the impact on the bandwidth actually. Okay, so here for example response time is in millisecond, but here it can go in minutes or days. Okay, and but the problem with the cloud is that you cannot have that much data storage is there. Sorry, in fog you cannot have that much data storage, but in cloud you can have huge data storage. Okay, and it's typically used in machine to machine communication. It is for analytics purpose actually. Okay, and this cover locally. Okay, because it's close to the node, but this is a global actually. Okay, so I think I've told you about industrial IoT. So it's very important actually for us, to control the, the operating conditions in a factory like a temperature, humidity. Okay, we need to constantly monitor, and it has to be, also, made available, to the mobile phone or through the net, because different people in the factory should be aware of it, because you have to understand in a factory, the environment conditions are very important, because from the warehouse to your production area to the testing area, because certain components has to be maintained at a certain temperature. Okay, so we need to have a some mechanism actually in place, so that you will monitor the temperature continuously, and you can control it actually, so that the temperature can be maintained constantly, and your the stocks could kept actually. Okay, or same way, manufacturing, you have to maintain certain temperature. Okay, so IoT plays a key role there, because you will have a lot of nodes. There you will have a sensors, you get the data, and it all can be accessed from your mobile. And if you have any problem, you will get to know get to know about that, and also you'll get alert, and you can also remotely control, the temperature and humidity in a factory. Okay, so that is possible. Okay, in IoT, industrial IoT. So, and this is one part of it. Another is that I think I've told you before. Now everything is going in a digital factory, so that is industry 4.0. So where we have to automate a lot of things, and also we have to do a real time monitoring. So earlier what used to happen is that once you start production, you will get the parts from the stores or warehouse in the company. Okay, and then you will start assembling it, and the product will be assembled in different stages by different people. Okay, and each of the stages you will do some testing. Okay, all of the things were done manually. Okay, and then you will have the data. For example, you will measure the signals on oscilloscope, you'll have the data. Okay, but this data will not be immediately transferred. Okay, so suppose if there are some problems, so then typically what happens is that the production team will inform R&D, and the engineers will look into it. Okay, so this all take a really time. Okay, and another thing is that once you do a manufacturing, and if there will be multiple stages, right? So what happens in one stage is, if you take more time, the other stage person will be idle. Okay, so we'll not have a proper control on that. Okay, so with the help of IoT, what is happening is that you will know. Once when the product the assembly gets started. Okay, and you will know about the stocks, because there will be RFID tags. So once one part is consumed, you will get the stock details. Okay, and once the part has come to one line, assembly line. Okay, and after the assembly, it will pass to the next level, where all the key management people will be alerted. Okay, so they can see it in their laptop. They will see the product is in the which stage actually. Okay, so they will get to know that. That's one thing. Another thing is that if you have a any problems with your testing actually. Okay, so all this information will be available directly on the net, and somebody can access it, and they can look into the oscilloscope data and so on actually. Okay, so you've got a better control there. This is the how the electronics manufacturing service companies are working. For example, you might have read recently, Apple has started manufacturing iPhones in India. Okay, so in initial manufacturing, it's very important for the companies to monitor each and everything, whether the measurements, everything, because we need to have the real-time access to the data, so that you can ensure that the data is done. Otherwise, what happens in the earlier scenario was that you do the testing, and later after the testing you will mail, so there is a delay. But with that delay, what happens is that by the time you get the email, the production might have gone to much less, further. Okay, so suppose if the measurement they done is not correct or wrong, there are some problems, then you need to stop it actually. So this will all cause a lot of delay. Whereas in case of real time monitoring, you can access it directly. You can see it is the things going in right direction. Okay, if there are problems, you can also look into it actually. You can perform additional tests. This will all prevent stop a lot of wastage in time, because if the results are not good, we can immediately alert the next line that okay, yeah, there is a problem, you could consider do some other task. Okay, and also R&D can ensure in real time. This is the most important advantage of IoT. Okay, and also the management is also at can higher level can say. Okay, so by doing all those things, what we are ensuring is that we are ensuring the problems, technical challenges or the issues in the productions can be solved remotely. That's the biggest advantage. The second advantage is that by doing this thing, we will get to know at when production is in which stage, and okay, by doing that, we will also get to know how much time is required in each stages, so that we can efficiently plan the production, so that we can reduce the wastage time actually. Okay, but that by doing that way, you can have a lot of cost saving. That's why IoT is very critical, and it's part of industry 4.0, and it's an essential thing in digital factory. Okay, so it is a complete control system. You have physical systems where you have a lot of things. It's machines and other things where you have a cloud computing. You'll have a local edge computing, because edge computing play a key role there, because you need to have local servers, where you need to analyze the data, because you can't have a cloud always, because the problem is that sending the data and the response, all those things will take time. So that's why we need a cloud, I mean sorry, edge computing actually. So that's very important. And you really need to do a lot of data analytic and say AI algorithms and other things. Okay, all these things are important actually, because we need to continuously analyze, and finally we have to optimize, our production time and other things. Okay, so this is a key goal in IoT in industry. So I mean, in industry IoT, you have a device layer, network layer, a service layer, and content layer actually. So in the device layer, you will have all the hardware, machines, and sensors. Okay, the network layer will use various kind of protocols, cloud computing, etc. In the service layers, you will analyze the data. Okay, and you will also manipulate, or even you can use it for analysis purpose, and or to create a dashboard, etc. Okay, so then finally in content layer, what you'll be doing, you'll be displaying the data. Okay, because all those things are essential when finally our goal is to improve the things. Okay, so that is where all those things are coming in picture. Okay, okay. Sorry, yeah. So bit on security. So as you know, when this, I mean, the advantage of IoT is, you can connect a lot of things. You can control a lot of things remotely. So for example, you can control your car. All those things, it is possible actually. But the biggest, problem is security. Okay, somebody could hack your data. They could manipulate the data. Okay, and for example, you have NFC communication. It is commonly used for reading the data in the credit card. But as you know, this is having a lot of other impact, because somebody could steal your data. They could steal your password and all of things actually. Or somebody could intercept additional message and block it. Or suppose you have a factory where you'll be storing, I mean, in a factory warehouse where you'll be storing all the food items and also on. Okay, where you have to maintain it minus, maybe minus temperature. Okay, somebody could hack it, and they could change the temperature and to make it to say 10 degree or 20 degrees, so that way they could do it purposely actually. So these are all various things, the challenges actually that is faced. Okay, somebody could stop the operation, somebody could manipulate to change it actually, and all of the things. Okay, so there are a lot of things we need to consider, like we need to have a lot of encryption algorithm, a lot of keys and other things actually, and we need to do some cryptography techniques and all, to prevent these things. So that is a really really essential actually. Okay, okay, so there are two type of attack. One is a passive attack, or other is active attack. So in the passive attack, somebody will gain the knowledge of the communication, what is going on actually. Okay, and in the active attack, so they will try to get into your system actually by replying to, say, some old messages, or sometimes they will try to get into your network, to considering that they're another entity actually, and unauthorized the entry they will get actually. Okay, then they will do the things actually. One is that sometimes they will do denial of service attack actually. So so they will disrupt the network itself actually, so that others cannot access, and also they may disrupt the alarm notification. For example, in your factory, if the temperature is going up, so you will typically get an alarm. So they could alter it actually, or they could stop it, they could alter it. So that's a possibility. Another is that jamming. So that's a common thing. This is very common, much common in defense and all actually, because they can create a high power signal actually. Okay, so that could interfere actually your signals and all. So that is creating a problem for you. Okay, so this is one of the challenge actually. Okay, So then you can create a fake traffic actually, like traffic injection. So this will again create a problem actually. Okay, so I mean these all things can cause a lot of problem actually. Okay, so you need to have some security actually. I mean some link layer security that is required actually, and also you need to have some encryption technologies actually. So that is also very important. Okay, so security is very critical. Okay, so you need to always consider the few things. So one is that you need to have an encryption technology, that's again important. Okay, so they need to have some hash function actually. Okay, so that will help somebody to alter the messages actually. Okay, so that's again important. Then we need to have some digital circuits or keys etc to access. Okay, so then firewall is another thing actually. Okay, all those things are very essential in IoT. Okay, so these are all software in generally you can say, but there are another hardware attacks as well. Like somebody could access your chips. It could somebody could disturb your power supply. Okay, so that could create a problem. Okay, so that's one thing. Another is that somebody could access your remote memory and you could rewrite the data. Okay, or you could affect the operation of your system, or even you can change the clock in your system actually. So that can affect, or somebody can corrupt your data. Okay, and or somebody could also alter the operation of your crystals and other things, yeah, or modify the software etc. Okay, so that's what I told you. OS is also very critical because they could directly come to the OS and they could affect the operation of your Wi-Fi and or various communication protocols etc. Okay, so there are a lot of different kinds of possibilities of attack actually. So somebody could do. So it's important for us, to have a different mechanism to prevent this thing. Okay, so in hardware you have certain techniques available actually. So one is memory protection, because somebody could access your memory. For example, in your memory, in your program, you will have some threshold set. Somebody could change the threshold, right? I mean, it's very much possible. So we need to have some memory protection there, so the data protection, and that's very important. Okay, so we need to have certain algorithm actually to do that. Somebody want to access your memory, so they need to you know have some signature or keys etc. So these are important actually. Okay, and also somebody is trying to disrupt your batteries and other things, so you need to have additional battery backup actually for that. You need to also do a lot of clock monitoring and voltage supply monitoring actually. All those things will prevent your system from attack actually, because somebody is trying to attack, they would disrupt your system. So you need to have a good monitoring of various parameters. Okay, so then region-based memory protection is common thing where you'll have some security, some secure regions in the memory where you'll have save the data actually. Okay, so that nobody could access it easily, because we need to have a certain keys to access. So that will protect. Okay, and then this is a rollback attack protection. So sometimes what somebody can do is that typically in a product in the market, you will launch it with certain software firmware versions, for example. So what happens is that there will be certain issues, and over a period of time, you may go with a new version of the firmware. So when you go for the new version of the firmware, you may uh, you know have some new features actually. Okay, so sometime what, and it may fix certain bugs actually. Okay, so somebody could hack, and they could change the firmware version actually, and it could run on the old firmware actually. Okay, so that's a challenge actually. Okay, so there's a problem, so we need to have some protective mechanism. Okay, so in place actually. Okay, so they should not able to access actually. Okay, so that is the problem. So they, but they could, or they could even change your firmware. These are all things actually possible. Remotely you can access it and you can download, because nowadays you can change the firmware through Wi-Fi. Not Wi-Fi, through wireless communication protocols. You can access your system say through Bluetooth, and you can change the firmware. Okay, so all those things can be, they can do it actually if they have control, so that your system may not work the way it has to work. Okay, and then so some of the security performance techniques you need to consider, that you need to have some battery backup, and you need to have some keys, or say say like digital signatures. So these are very important actually. Or so you need to have some encryption and decryption things actually in place. Okay, so that nobody could access your system. Okay, so the firmware attack, somebody could access the data, they can change behavior and so on actually. Okay, so these are all very much possible. Okay, So you need to have some protective mechanism, some key code generation or random code generation, etc., random generate, etc., so that nobody could accept your firmware actually. So we need to have a lot of mechanism for somebody to access your memory. Okay, so that's very important actually. Okay. So another thing is that somebody could tamper your system. Okay, so they could manipulate your system. Okay, they could change the behavior of your system in that way, like so in your system you will have a certain conditions like over temperature or under temperature which will be there, right? This they can change, or somebody could reduce the voltage, or they could change the clock frequency. All those things are possible. Or for example, you operate, they can have a say some sort of devices operating near to your sensor, so that could affect the operation of your system's clock. Okay, so all those will have impact actually, and it could affect the operation. Okay, so you can have some sensors, voltage monitors and clock monitors, etc. All those things will alert you actually. Okay, somebody is trying to do something, so you'll immediately get to know, yes, somebody is trying to hack our system actually. Okay, so these are all things will help you actually. Okay, so we need a lot of protection keys as well actually, so that nobody can do anything to us. Okay, so these are all the things you need to consider. So IoT is used in various applications. So in healthcare, it is very popular. So nowadays, due to COVID and other things, we need to monitor a lot of things remotely, and you need to try. You can transfer the data over a mobile phone. Actually, for example, in home monitoring, where you can monitor your ECG. Okay, nowadays, you have smartwatch where you can see your ECG, and it can be immediately transferred to mobile phone, or to PC. Or somebody doctors could access it, and all those things. Okay, so doctors can analyze your data and do the analysis remotely, and you could prescribe you the medicine or diagnose the things actually. So there's a key actually in healthcare. It is very very popular. And automotive you take, I mean, in your car, you have a Bluetooth and all of the things, right? You can download the music, I mean, from your mobile, and you can see. Okay, so that's one of the IoT thing. Or nowadays in car you have a internet actually. Okay, so you can download the data, images and whatnot actually. Okay, and these are standard things. In addition to this, now you have autonomous cars, where car will communicate with each other to other cars, so that it'll operate accordingly, automatically it can drive, or it could also alert other cars in case of break, or there is some problem with the system. Okay, so these are all common things. And in industrial, as I told you, it's very critical, and it's the one of the major applications actually of IoT, because in a factory you have to control a lot of things. Okay, in larger factories you have a lot of things to control, from the lights to the temperature to humidity, to various pressure. I mean, in the flow control, a lot of things actually. Okay, so all those things are important, because you need to control. At the same time, you need to also inform the factory management also. They should able to see everything in the app, mobile phone app. When they open the app, they will get to know, yes, everything is normal, and if there are some issues, it has to be alerted, so somebody could immediately come and control it actually. All those things are important. Okay, and power, the light control, this all for energy saving actually, so this is again important. So this is all one of the major I mean, applications of IoT. So it's very well used in the home. You can control the various devices in your home from your mobile phone or from net actually. All those things are possible with the help of IoT. Okay, because we have a lot of things to communicate and control. You'll have control system at home, where I mean, that's called typically gateway, so that will manage everything. It will control each of them, and okay, it will alert you actually in case if there is some problem. Okay, or even before you are entering home, you could adjust, set AC on, and according adjust the temperature, so by the time you are in home, things will be okay. Okay, so these are various things. Many various type of modules could be used for IoT applications. So one of them is one from a microchip, like you have a ARM based, or AVR based process which you could use. So this PCB antenna actually. So which I was telling So it all depending on the application you could use. Okay, so there are a lot of other modules available. So you can use some of them actually for your development. Okay. Yeah. So with this I've done actually. So if you have any questions, you can type it in the chat box. I will answer. Okay. So in generally, when you are doing any project in IoT, few things you need to consider. One is that the important thing is you have to always uh, consider the power. Okay, so that's a basic thing you have to consider. Okay, where you want to use which kind of power source. The second thing is that when you are searching the such when you are selecting say the processor, you need to always consider whether the processor has got low power consumption, and also you need to look into the operating systems, because this is connected with each other, because whichever operating system you are choosing, that should support different kinds of wireless communication technologies like Bluetooth and Zigbee and Wi-Fi, etc. And the same time, those again, has to support different type of communication protocols. And then your the IoT the protocols, and the other things, actually, like all those things are linked to each other. Okay, so these are the things you need to consider. So you need to really see which kind of application you want to do, what kind of data you want to send, and what is the range you need. For example, you want to make a drone, for example, to acquire image data. There you need to have Wi-Fi modules, because you need a you have a large image data, right? And also you need to see the distance. Okay, so where you have a less amount of data, you could consider some other protocols. Okay, so these are the things always you need to consider. Okay, and also the OS you are choosing, so that should also have a low memory consumption, and it should support various communication technologies and protocols. So all those things are important. Then you need to also consider the support that you will be getting for your development. Okay, so because this is a key technology, and I mean, and this is a real future. And also you have to consider this thing in IoT at a large level. If you see, when it is coming to cloud, you also use a lot of AI and ML techniques there, because you need to analyze the data really. Okay, so it's not about individually you are controlling. For example, in home automation, it's not critical, but in a larger application like in industrial application, or in the traffic and other things, these are all very critical, actually. Okay, so it's a really broad this thing. It's a individual subject, I mean, in engineering or in ME. Okay, so you need to, I mean, I'd given an overview, so you need to go each and everything, and you need to go in deep, actually. So you need to have a good knowledge, in the electronics part of it. Then you need to have good understanding on which processor you need to choose, which communication technologies you should use, which protocols, I mean, and then the IoT platforms and so on. Actually, all are important, actually. So when you are doing something, you need to really look into these aspects and choose the right protocols, right module, right processor, and so on. Okay, so if you have any questions, you can unmute and ask me, or you can type it in the chat box. Hello, if you have any questions, you can type it in the chat box. Okay.
I think there are no questions, sir. Yes.
Okay.
Uh, and because everything you have covered is in detail and very nice fashion, so I guess everything is properly crystal clear to all the.
Thank you.
Okay.
Okay, so
So
can
thank
we
you very
close
much.
this session? Yeah, yeah, yeah.
Yes, sir.
Welcome.
Thank you very much for giving your precious time for this webinar. Thanks a lot.
Yeah, thank you. Bye.
And thank you, every participant.
Yeah.